Hey guys, what's up? Welcome back. Episode 61, I think. Right? Yeah, because we got 60 thumbnail here. I think 61. Um, yeah, probably well, yep. Episode 61. Yeah, sorry, I couldn't make a video yesterday. I kind of attempted to, but I got back really late and had a really long day. Had to help some friends with some homework and stuff and do some other things. I get groceries, so it was just clean my apartment. Just a long day, so um, I decided I'd make the video today. So yeah. Um, Other than that, yeah, just another regular week. Excited to get back into it, and yeah, let's check out our Pokemon sound of the day. I know a lot of people love this part, so me making the Pokemon sound. So whoever does watch this, yeah. So we're gonna look at Poliwall today. You can see I tried to make the video the other day, but yeah, take a look. Interesting sound. Ba-doop, 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 ba-doop. There's my Poliwall sound, baby. Interesting sound, but yeah. So yeah, we're gonna jump into a. Let's just take a look at our problem of the day. Ooh. I had a nice lunch, a little bit of yogurt and fruit. It's pretty good. It's pretty good. Seems like we have a easier problem today. Given an integer n, return true if it's possible to represent n as the sum of distinct powers of 3. Otherwise, return false. An integer y is a power of 3 if there exists an integer x such that y is equal to 3x. I'm wondering maybe if you just divide the number. You repeatedly divide the number by 3 until you reach 1. If at any point the division results in a non-integer value or leaves a remainder, the number is not a power of 3. It's a power of 3. Let's create a recursive function here where we pass in our value of n. We can create a, let's pass in like a recursive n. And we want to return here. We want to call the recursive function. We want to divide n by 3, right? And let's just return recursive n, right? Divide n by 3. We check, well, if n is equal to 1, then we return true. Otherwise, if n is equal to the... How can we check... If at any point the division results in a non-integer value or leaves a remainder, the number is not a power of 3. N modulus 3 is equal to 2, and we return false. Let's see how this runs. Bro, no way. No way. I just got that. Oh my gosh. So what if we had it, if n modulus 3 is equal to 1, if we have a remainder of 1? Okay. So why curious why. That is insane. I think that's probably a record time I've solved a question, I think. Let's just see if this submits. I'm curious. Like, wow. Beats 100%. I'm the GOAT. Wow. Interesting. I did not expect that whatsoever to solve that in maybe 2 minutes. I mean, technically, I didn't really solve it myself. I just had to check if numbers power of 3. Just kind of read the internet, but I'm curious to see why that this is 2 and not 1, because I think it said any sort of remainder leaves a remainder. The number is not a power of 3. If you reach 1 by dividing by 3 with no remainders, then the number is a power of 3. So if there's a remainder of 1, then why does that... I'm curious. I don't know. To be honest, I just put 2 because I thought that's kind of how to do the remainder stuff. Because I thought 1 was an odd number, so... how... Why is this not n% 3 equal? I gotta open the window here. It's a little warm in here. Get a little bit of fresh air in here, bro. Take a look. The reason why it is percent 0% false. Okay, because 0 and 1 is considered base 3. Base 3 is like binary. Wow. There you go. That's crazy, man. I think that's a record for this this channel here. Solving a Leetcode problem, or even just a Leetcode daily problem in what? That was maybe a minute and a half, maybe 2 minutes. Like, and it was a medium problem too. Kind of goated. Let's check the comments, though. It's probably going to be like, oh, people being like, oh, this is easy. Oh, we didn't even check the hints either. So, there you go. Backtracking gang. My intuition was that this is a pick / not pick kind of DP more than anything else, and it worked on the first 10. Not optimal, though, but it still worked. Okay. I have to respond to some text. Okay. Well, what should we do? I don't know. Let's take a look at our thing. I'm feeling like today's kind of like we change it up a little bit. Like we go into I really want to do some graph problems. Maybe not. Main traversals, level order traversal. DFS pre-order, in-order, post-order. Think about both recursive ways and iterative ways where you need to apply the knowledge of stack and queue. How to search, add, and delete nodes in a BST and their time complexities. Man, I keep forgetting. I was gonna print like a time complexity thing up on the wall. Yeah. I guess we just keep running through these problems here. What are we at? 22. I feel like this never moves, bro. Like, honestly, like, I mean, where are we at in hash table? Like, 35. Yeah, we're getting somewhere, but I think we got to start going through these BST ones. You know what I mean? Like, I know. I mean, I feel like these are important as well. So let's just start running through them. Like, 2 sum 4 input is a BST. Given the root of the binary tree and an integer k, return true if there exist 2 elements in the BST such that their sum is equal to k, or false otherwise. There exist 2 elements in the BST such that their sum is equal to k, or false otherwise. My dad's calling me. I will be back. I'm gonna pause this video and come back to it. So I'll be back. Alright, I'm back. Sorry, I had to talk to my dad for 10 minutes or so, yeah. Let's take a look at this problem. So, given the true binary search tree in k, return true if there exist 2 elements in the BST such that their sum is equal to k. So we add 2 elements that equals to k. So 3 and 6 is 9, so true. Guess the way that we probably have to go about this is, well, we pretty much have to check every element, no? Like, yeah, well, I'm pretty sure we'd have to figure out some way to check every element because we go from 5, because it's 2 sum 4. Wait, similar questions. 2 sum. You know, we'd have to go check this one, 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 then move, check this one, check this one, check this one, check this one. So, I don't know. Kind of, do I know how to do this off a BST? Not really. But definitely need some sort of hint because I'm not sure kind of hash table 2 pointers. Since it is technically sorted, not really too sure kind of how to approach this problem. Approaching the problem. Okay. Think about in-order traversal. I know each BST has an in-order traversal that results in a sorted array. You can traverse the BST in order and store the values in an array, then solve the problem using a 2-pointer approach. Okay. feel like that's kind of cheating a little bit. But hint 2, use 2-pointer approach. After storing BC values in a sorted list, use 2 pointers, one at the beginning, one at the end, and find 2 numbers that sum up to the target. Try a hash set for O1 lookups. Instead of using an array, you can use a hash set while traversing the BSC. As you visit each node, check if target minus node value is already in the hash set. If yes, return true. Ooh, that's very smart. I did not think about that. You can use a hash set while traversing the BSC. As you visit each node, check if target node is already in the hash set. If yes, return true. Otherwise, can you do an O1 time and O page space? Use a BSC iterator with 2 stacks to mimic the 2-pointer approach. 1 stack is used for small elements in order to traverse on the other for largest elements. Okay, we're gonna try hint 3. So let's create a hashy. Hashy is equal to set. And we want, as we visit each node, we want to check what was the target minus node value already in the set. I'm trying to think here. Let's do a DFS approach where we input our root, do a while stack, and then if stack. Sorry. Node is equal to stack.pop. We want to add to our hashy, right? Add our val, so hashy.add, node.val. And then I want to check, well, if hashy has seen the value before. So we would do if k minus node.val in hashy, then we can return true, right? Otherwise we want to do, well, if node.left, then we can append, if node.left, we can stack.append node.left, and then if node.right, we can stack.append node.right. Otherwise, we can just return our stack, I guess, right? But we need to do, well, if not root, return false. I guess, well, what if the node is empty? Check if empty. If not node, then we just, well, if not node, we just probably continue, right? Okay, let's see if this runs. This needs to be oh, wait, what? I'm so confused right now. Oh, return, sorry, false. Jeez, man. Jeez. Is this gonna submit? Nope. Nope, 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 nope. How is this turn true? Oh, I'm checking this after. I think I gotta check this before. I think. should be celebrating. I mean, bro, like, nice, dude. Nice. Nice, nice, nice. Okay. Let's jump to our next problem. I'll be back again. My sister's calling me now, so I'll be back. Yo, I'm back. Sorry, sister called now. Yeah, let's keep going. Let's take a look at the maximum binary tree. Oh. Given a integer nums with no duplicates, a maximum binary tree can be built recursively from nums using the following algorithm. Create a root node whose value is the maximum value in nums. Okay. Recursively build the left subtree on the subarray prefix to the left of the maximum value. Recursively build the right subtree on the subarray suffix to the right of the maximum value. Let me respond to this text really quick. Okay, pretty root node. So I think maybe with this one, we were looking at some other hints. Maybe we got to make this into an array and do. I don't know. They give us a numbers array list of values. Oh, okay. Create a root node who's the maximum value. Okay, we create a list, right? We find our max. Well, how do we find the maximum value? Can you find max value in array? Way to find max value in array. Ta-da. Is there a max method? Okay, that's what I thought. Okay. Oh my gosh, dude. Max val is equal to max nums. Let's print out max val just to make sure. Where did I? Is not name recursion is not defined, bro. What the? What are we going on about here, bro? Oh, whoops. Whoops. Six. Okay, output. Nice. No, it's 321605. We got an act here. Alright. Let me think. How can we do this? Code on left is 3. Student. Recursively build the subtree on the subarray prefix to the left of the maximum node. Recursively build the right subtree on the subarray prefix to the right of the maximum node. Okay, so we go from wherever we're at here. So I guess we gotta find our array for left, and then we gotta find our array for right. We use slicing for that, right? So we would slice from Oh my gosh, dude. My dad's calling me again. I'll be back once again for the third time. Hopefully the last time. Okay, we're back. Another call. Okay, so we find our array. Find our array for left, slicing. Okay, how are we going to slice? We need to slice from this number to this number, but we need the index value to slice, so... Can you get the index value from this method or something? Oh, guess they built a subtree. So maybe we can go, well... I mean, how would we do this? We need to do like 2 pointers or something. Let's check here. Instead of slicing, you can pass indices to define subarrays. Pass indices to define subarrays. This needs to be tree node. Whoops. Okay. We created our dummy. Yes. I guess. Let's change this to root. Let's create our root node. So our root node is going to be our max here. Get rid of all these. We got our max value. Nums.index. You know, this is an actual method, nums.index, but that's pretty cool. So this finds our max value, right? So then we want to find our array from the left. Wait, what am I doing here? Max index is equal to nums, max nums. Then we want to create our root node, right? So we want to do, well, root is equal to nums dot, sorry, no, root is equal to tree node. We want to pass in nums max index, right? And then we want to array from the left, so I'm going to do recursion left. Right, so we do, well, construct maximum binary tree. We want to pass in our root. I'm not sure. I don't know. How would we do this? Okay, so we do it like this. So we go root.left is equal to construct maximum binary tree root. Then we do root.right. Recursion right. Root.right is equal to construct maximum binary tree. We put in our root. But we'd wanna, and we need self keyword. And I think here we'd want to slice up until our max index, right? Something like this, I think. And then to do the right, we would go, well, max index to nothing, right? Okay, I was right here for the left. This goes from nothing to the max index. Max index. We don't want to start from the max index, right? So we want to do max index plus 1. Ah, that's what I missed. Plus 1. Okay. We return our root, right? Yeah. Oh. What is going on here, bro? Construct maximum binary. Ooh. Got a typo here. Tree node object is not subscriptable. So I think it's saying it's like not iterable, I think. I don't know. Oh. Have to check, well, if there's nothing in it. If not nums, then we just turn root, I guess, right? I mean, well, root doesn't exist at that point, so I guess we just return, well, I guess just like an empty or something. I don't know. Maybe it's none. Why is it not subscriptable? Oh my gosh, that's why, bro. Oh my gosh. This has to be nums, bro. Okay. Is this needed here? I mean, checking if there's nothing. Yes, that's just an edge case. Okay. Max arg is an empty sequence. Okay, so that's how you know. So we need to do well. If not root, you just return. Sorry, if not nums. That's what I meant. Sorry. Nice, dude. Now, there is for sure a faster way. Can we do this? Unrecursion way? Well, in range, length. Max index. I think we go to max index, right? Is that the right valid syntax? I think we go to max index, right? Okay. Then we do what? Node dot left is equal to I. Thumbs up. Yeah. This is definitely not right for sure, but we go from max index to the length of nums. +1 though. To the length of nums, and then we would return our root. Node is not defined, so it's meant to be root. Usually use node, root here. True, the object has no attribute left. Would this work, dude? Okay, yeah, but can you do it iteratively? That's what I'm asking. I mean, you should be able to do it iteratively, like a metonic stack. Okay. Yeah. I mean, I need tree node objects here, so we're going to have to use some sort of recursion here, but interesting. Yeah, I'm going to kind of look back at the stack approach because that seems kind of interesting. Maintain a decreasing order in the stack while stack and stack match on the values less than num. What do? They create a stack. 4 dominoes, node is equal to 3 num. While stack and the top of the stack. While stack is not empty and the top of the stack is less than num. Node dot left is equal to stack dot pop. Guess they have a metonic stack right here, don't they? Yeah, they do. Oh no. Interesting. Yeah, you know. Let's leave it at that. Let's jump on over to a different one. 24 now. All elements in 2 binary search trees. Let's check out this one. Given 2 binary search trees, we want to return a list containing all integers from both trees in ascending order. Interesting. Okay. What's the best way we can combine these? Well, we could obviously split them up, make them into an array, and combine them. Sort the array. Could do that. Traverse the first tree in list 1 and the second tree in list 2. Merge the 2 trees in one list and sort it. I guess here we're gonna have to think about like maybe what sort of traversal to do. A pre-order, in order, post order. I always forget though, dude. Like what? Pre-order, typically root left, right. In pre-order, you visit the root first, then recursively traverse the left subtree, and finally the right subtree. Visit the root node, traverse the left subtree, recursively traverse the right tree subrecursively. Pre-order, root, left, right. In order, traverse the left tree, visit the root node, traverse the right subtree. Post order, traverse the left, traverse the right. Okay. Well. Okay, let's just traverse the left tree first, right? So we do, well, stack is equal to root, right? So in this case we have root 1. While stack node is equal to stack.pop. Let's create our list here. Create our res array that will sort at the end. Right. We can go here, get rid of this crap. Come over here. We pop the node. Then we while stack node.stack.pop. Then we want to traverse here, so we want to do, well, we need to check both children, right? Sorry, no. Yeah, we just check here. Then we add to our list, add to list. So we do like node.val, or res.append, node.val. If node.left, then we just append stack.append, node.left. If node.right, then we just stack.append, node.right. So this is a in order traversal, right? You traverse the left traverse, then the root. No, this is in order, right? Bro, tell me. Root left, right, pre-order traversal. So this is a pre-order traversal that we're doing here. I don't think it really matters what sort of order we do, because I mean we've got to sort it at the end anyway, so let's return our return res, bro. Two, 4, 1. Okay, nice. Okay, now we do the same thing that we traverse other tree, right? That's right tree. Alright, we traverse here. Put this to root 2. We make this. Let's make this stack 2. Stack 2.pop. Okay. Then we just return, well, we return our return sorted res. I put 1, 2, 4. Stack 2. I forgot that. I think this should work. Oh yeah. Boop, 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 boop. No! Tribute has no attribute val. Oh shit. Okay. If not node, let's continue. Right. If not node, we just continue. There's gonna be some other fucking edge case, dude. I'm telling you. Oh, okay, we're good. Nice. Cool. Let's check out other ways other people did it. Man, bro, this looks so complicated, bro. What the hell is this? Break this problem down into any sorted array problem in which we need to make a sorted answer from two sorted arrays, so we convert the trees into sorted arrays, and it's really easy to get answers from two sorted arrays. Bro, jeez. Solve.stack. Bro, this, like, bro, I don't even want to read this, bro. Okay, let's actually just try and read it. So they create a stack here. They push the root. Okay. Get all elements. They call the auto root 1. Auto root 2, getting the next values, you know. Creating a sorted array from two sorted arrays. If and then I think they sort here at the end. So pretty much I think they have just like a helper function here that iterates it using in-order traversal or simulates an in-order traversal, and then they pretty much sort it at the end. Which I still think my solution is, I mean, yeah, I don't know. This guy uses DFS. If not, return this. Return DFS root.right plus node.val root.left. Interesting. Yeah, nice. Kind of blasting through these problems a little bit low key, but yeah, you know, maybe let's look at something else. Leave a couple of these problems for tomorrow. Oh, let's take a look at a hash map problem. We're nearly done with these, so maybe we do the intersection of two arrays. Given two integer arrays, and as one of those two return an array of their intersection, each element of the result must be unique, and you may return the result in any order. 1, 2, 2, 2, 2, 2. 4, 9 is also accepted. So 2 is an intersection. The intersection. But what is considered an intersection? Each element must be unique, and you may return the result in any order. Oh, jeez. To be honest, bro, I don't really know, dude. Four nine five 949 84. 221 222 495 949 84. bruh. To be honest, I don't really know kind of how to logically like think about this. I don't even know. Is it? Nine four four nine is also accepted. I don't know. Why? Array of their intersection. You tell me the result must be unique. And you may return the result anyway. I feel like the description is kind of poor, like a little bit. Yeah. Common elements in two arrays. Okay, common elements between the arrays. So 2, 4, and we got 4 and a 9 over here. Okay. I mean, I feel like the best way to do this is with a hash set, no? Where we hash is equal to the set. And then we have a res array as well that we return. Loop through for I and nums. We add each value to the set. Hashy.add I. Then we loop through another one for I in nums2. If hashy in, sorry, if I in hashy.add, sorry, we want to do res.append I. Maybe we just return res. Maybe we can make this a set. Make it a res, but make this a hashy as well. And just return the hash set. Res.add I. Return type list. I guess we can just cast this into a return list res. I mean, is that really the best way to do this problem, bro? Like, using only Boolean array, bro. What the? What is this, dude? Simple trick. What are they doing here? Return list, set nums1 and set nums2. That's pretty much what I did, but I just got to do hash map count array for I and nums1, hash map I is equal to 1. For I and nums2, if I and hash map I is equal to 1, counter. Anyway, that was an easy solution right there. Let's take a look at some. I mean, bro, we've been kind of flying through these problems. I mean, I don't even know if we've been going for an hour, but let's maybe take a look at blind 75 or something. Maybe do a couple problems from there. Maybe we can check out some old problems. Weekly rating. Bro, there's no way I'm, bro, chugging all these problems. I mean, bro, we got a few backtracking. We got a few. See, these are the ones I kind of really need to look at a little bit more. We will get to that. I know we will. This be a good one as well. Maybe doing a little bit of heap work. I'm wondering kind of how that works a little bit. Sacred greatest common divisor of strings. Let's try and see how many we can do. Maybe we can do most of these pretty quick. I don't know. For two strings S and T, we say T divides S if and only if ST. T is concatenated with itself one or more times. Given two strings, string 1 and string 2, return the largest string X such that X divides both X1 and X. This is an interesting problem. Both string 1 and string 2. For two strings S and T, we say T divides S if only S. T is concatenated with itself one or more times. Given two strings, string return the larger string X such that X divides both string 1 and string 2. My intuition here is kind of using a set as well, I think. I think a set is probably the move here. Is it? I don't know. Because really we can... I'm thinking maybe I can set be used with characters. Okay. Alright. I'm gonna try it. I'm not sure. I think we loop over this, add it all to a set, and then we loop this, the numbers here, we add it, right? Because I don't think it's going to hold AB, and if it does, I don't know. Let's just take a look. I'm not really too sure. The problem is kind of a little bit confusing, I think, but... I don't know. This probably isn't the answer, but this is kind of... Let's do, well... Let's create a set. Hashi is equal to set. Let's do for I in nums. I in nums. We can do, well, hashi.add. Or I don't think this will work, dude. So maybe you get a hint. Let's get a hint, because I'm curious. Like, I don't want to do this because I don't think it's gonna work. Okay, I'm honestly not sure. It's given me some interesting approach hints. Check the length of visibility, forming the GCD string. Then the string is a GCD string. What is GCD? Length of GCD string must be divided by string 1 and string 2. So start by finding the GCD of the length string 1 using the Euclidean algorithm. I have no idea what that is. Let's take a look at the Euclidean method of finding the greatest common divisor out of two knowledge. So first we have to find the greatest common divisor of the length of these strings. How do we do that? We take L1 is equal to the length of string 1. L2 is equal to the length of string 2. Yeah, bro. Honestly, this is a tough problem. I actually have no idea, bro. Like, let's take a look at this problem. I'm sure Leetcode has a video on it. Oh my gosh, dude, I cannot copy this, bro. What the? Okay, bro. Whatever, bro. Whatever, bro. Greatest common divisor strings.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem greatest common divisor of strings. We're given two strings S and T, and we say that T divides S if and only if one of the strings can be made up by adding the other string multiple times. We could add it twice or 3 times or more times. Maybe even the two strings could be equal. Now, given two strings, our goal is to return the largest string X such that it divides both of these strings. Now, that doesn't necessarily mean that string 2 will divide string 1, because as we can see from this second example, we can't add this string twice to make this string, but there exists a substring, AB, which can make this string by adding it twice and can make this string by adding it 3 times. And also, don't let the problem trick you into assuming that string 1 is going to be longer than string 2. That's not necessarily going to be the case. They just tell us we're given two arbitrary strings. Now, there are many ways to solve this problem. Some can go really deep into the math, but I'll keep it pretty intuitive. You don't need super fancy math for my solution. So how can we even brute force this problem? Well, we can't just come up with our own random substring X. Let's try to take a substring from one of these two strings, such as this one. We can try A itself. we can try this one. It's length of 1. Let's see if taking this and creating 4 copies of it, because this string is length 4, we have to create 4 copies of this. Does that create this string? Well, that would create A. That does not equal this string. Next, we could try the first 2 characters, which is of length 2. So how many times would we need to add it to make this string? Well, we would need to add it twice because this is of length 4. So this is kind of where the math intuition comes in. First of all, we're trying substrings from this one. Why did I choose this one? Well, because it's shorter than this one. We know that if we get all the way up until here, like this entire string, and we tried every previous substring and none of those worked, then creating a longer substring than this isn't going to work. That type of X added together will never create this string, because adding them together, we have to create this string and we have to create this string. So that's why we go with the smaller one, though it doesn't make a huge difference, I think. But more importantly, when we have a candidate X, we take the length of this candidate X, and we want to make sure that it is a factor of the length of this string. Because if it's not, then it will be impossible to create this string. Such as, for example, if we had this string of length 3, adding this together will never create a string of length 4. We will, though, be able to create a string of length 6, but that's not our goal here. We need an X that can create both of these strings. So another way to put it is when we have an X, we take that length of it and we make sure that the length of this string, which let's call L1, we can mod it by this length. And when we mod it by this length, there should not be a remainder. So this should equal 0. If it's not equal to 0,
Zoned out a little bit, bro.
4. We will, though, be able to create a string of length 6, but that's not our goal here. We need an X that can create both of these strings. So another way to put it is when we have an X, we take that length of it and we make sure that the length of this string, which let's call L1, we can mod it by this length. And when we mod it by this length, there should not be a remainder. So this should equal 0. If it's not equal to 0, we're not even going to try this candidate. And we want to make sure the same is true for the other string too. So we make sure to mod it by the length. If it's not equal to 0, then we don't do it. But if it is equal to 0, then we consider it. And how exactly do we consider it? Well, when we have a candidate like X, how many times would we have to add X together to create a string of length 4? Well, we can get that by taking 4 and dividing it by the length of this candidate, which is 2. That gives us 2 times. 2 times X is going to create this string. What about this guy? Well, it has a length of 6. So we take 6 divided by 2, which we get the 2 from the length of X, and then we get 3. So we need 3 copies of it to create this string. And then all we do is check, and then we just add it 2 times. Is it equal to this? And add it 3 times. Is it equal to this guy? If it is, then we return the result. One last thing we can do is that instead of going from smallest to largest, we can be a bit greedy and try the longest possible one first. Because remember, we're trying to find the largest X. So let's start being greedy. Let's start with the 4. Well, 4 doesn't divide with 6, so we can't even try it. Then we try 3. Well, it doesn't divide with 4. Then we try 2. Yes, it divides both of them, and it does create both of them, so that's what we would return immediately. So to analyze the time complexity quickly, since we're going to be iterating through the smaller string and checking in the worst case every substring of that, that's going to be our X candidate, we'll say that to do that, we're going to need to iterate between the minimum of M and N, where let's say M is the length of this guy and N is the length of this guy. And then every time we do that, in the worst case, given a candidate X, we're going to need to build this entire string, which is of length N. And we're going to need to build this entire string, which is of length M. And the time complexity to do that is going to be N plus M. And we multiply these two together because this is what we're going to call inside of that loop. So this is the overall time complexity. Now let's code it up. So we're going to start with the length of each substring, and then we're going to iterate through where L, this is an L, maybe I should make it capital, but I'll leave it lowercase for now. L is in the range of the minimum of length 1 and length 2. And then we want to check if isDivisor. I'm going to create a helper function to do this, where the substring, we can pick either one, string 1 or string 2, because if it's a divisor of one, it has to be a divisor of the other. So we'll pick just arbitrarily starting with string 1, so a substring going from the beginning all the way to L. Oh, and I forgot, with our loop, we want to actually iterate not starting from 0, but we want to start at the number itself and then iterate down, going down -1 each time. But this substring, we picked it from string 1. We could have picked it from string 2, and the result would be the same, because remember, x, whatever it is, it has to go into both of the strings, and that's what we're going to check in our isDivisor function. Now, if this were to return true, that would mean we found our result, because we're doing this in a greedy way. So we would just return that string, string 1, going from the beginning up until L. And if we never find it out here, then we can just return an empty string. I think that's the default. Now, to actually define our helper function, let's call it isDivisor. It'll be given some length L. First, we want to check that L is a factor of the length of both strings. The easy way to check that is length 1 modded by L. So if this is non-zero, or if this is non-zero, then we know it's not a factor, because it has to be 0. So if it's not a factor of both of the strings, then we just return immediately false. We know it's not a divisor of both strings. But if it is, well, at least the length of it is a divisor, then we want to actually try to build the string. But how do we build the string? Well, I'm going to create a couple variables, f1 and f2. These are going to be like the factors. I guess I should write out the entire variable, but I really hate writing out variables in Leetcode. So to get f1, we're just going to take the length of string 1 and divide it by L. We're doing integer division in Python, because we need to round down. Well, this would never be a decimal anyway, because we made sure that it is a factor, so I guess you don't really need that, but I'll leave it anyway. L2 divided by L. So these are going to be the factors. This is going to tell us how many times we have to multiply. So when we take string, that substring we were talking about, our candidate L, this is it. We're going to multiply that by F1, and we want to make sure that this is equal to string 1. And we also want to make sure that this is true for string 2. So here we just changed this to F2, and we changed this to string 2. You could say we need to change this to string 2. You could, it would work, but it'll work in both cases, because remember, our candidate is going to be the same for both strings anyway. And if both of these are true, we return true. If they're not, we return false. So we can literally just return this entire value. Oh, and quickly, I just noticed that here we're passing in the string. We don't want to do that. We want to pass in L itself. So this is the entire code. Let's run it to make sure that it...
Measurement like 2, 0, -1. Okay, let's take a look at this over here. Okay, so we grab the length, right? So length 1 is equal to the length of string 1. Length 2 is equal to the length of string 2, right? We do for L in range, and then we start from min of length 1, length 2. So we take the minimum of these two, and then 0, and then we go -1. So I know we're counting backwards here from -1, so we start from the top. I just forgot what the middle value is, dude. What is the middle value? What is middle value in Python? Loop? Start, stop, step. Okay. We start here. So we're starting from the top, we stop at 0, we iterate -1, so we go from behind. Okay. Okay. Let's take a look at this now. So we do that, then we pass in our helper function, is divisor, hell. If it is, then we return that string, right? So we're checking, well, is it a divisor, right? Can you divide, can you evenly divide from here? You know, in this case, we're looking for 2, we're looking for 3 here. So, is divisor, taking a parameter L. I have length 1. Does not equal 0, and length 1%. Set L does not equal 0. This is meant to be 2 here. Well, if we want to do 1 min L.
Both strings. The easy way to check that is length 1 modded by L. So if this is non-zero, or if this is non-zero, then we know it's not a...
If it's non-zero, that's what I've got here.
factor, because it has to be 0. So if it's not a factor of both of the strings, then we just return immediately false. We know it's not a divisor of both strings. But if it is, well, at least the length of it is a divisor.
Yeah, it returns false, right? Otherwise, if it doesn't, then we want to return, well, f1 is equal to length 1 divided by f2 is equal to length 2 divided by L divided by L. So L times F1 will be equal to string 1. We wouldn't really need this anymore. Turn empty string.
Anyway, L2 divided by L. So these are going to be the factors. This is going to tell us how many times we have to multiply. So when we take string, that substring we were talking about, our candidate L, this is it. We're going to multiply that by F1, and we want to make sure that this is equal to string 1. And we also want to make sure that this is true for string 2. So here we just changed this to F2, and we change this to string 2. You could say we need to change this to string 2. You could, it would work, but it'll work in both cases because remember our candidate is going to be the same for both strings anyway. And if both of these are true, we return true. If they're not, we return false. So we can literally just return this entire value. Oh, and quickly, I just noticed that here we're passing in the string. We don't want to do that. We want to pass in L itself. So this is the entire code. Let's run it to make sure that it works. And as you can see, yes, it does, and it's pretty efficient. We're passing in the string. We don't want to do that. We want a ton of free resource. If this was so.
I put ABC, ABC. What did I do wrong here? Why is this? I think we got something wrong here. Whoops.
This is the entire code. Let's run.
There we go. Okay. So we gather our lengths. We follow the arrangement. We get the min of this. We start from the top. F is divised at L. let's kind of walk through this code a little bit. So we would do, well, so we start, let's use this. We use string 1 equal to ABC ABC A B C string 2 is equal to ABC right. We do okay. We loop through our value, we take the min of these. Obviously the min of these is going to be 3, right? So we're going to start at 3 in our for loop and we're going to iterate. Okay, so we're going to start with 3. We're going to do our is divisor method here with 3. Our is divisor method. We're going to get f1 is equal to the length of 1, so 6 divisible by 3. Now f2 is going to be 3 divisible by 3. So it's all 0, so we're going to skip that. We're going to do length of 1 divide by, sorry, let's get rid of this. We're going to actually skip that. We're going to check, well, length 1 modulus L, length 2 modulus L, right? And we check, well, our length 2 and the length 6, we got 3, and then we got 3 and 3, right? So it's 0. It's all equal to 0, so it passes, right? Let's make that a tick in yellow, baby. Passes, right? We can come down here, and we do, well, whoops. Okay, for some reason, you know, we're gonna just go with it. Alright, that's whatever. We're gonna do f1 is equal to length 1 divided by L. So we do 6 divided by 3 equal to 2. And then f2 6 divided by, sorry, 3 divided by 3, which is equal to 1, right? And then we're just going to return. If this returns true, then we found our thing. We return string up to k, string 1 up to L. So L in this case is 3, so we go up to 3, and then we do times by f1, so we get ABC, right? That's good. And then we get up to L up to here. We got ABC over here, but then we times it twice, so then we get ABC, ABC. This is all correct, looks good. And then we return H sliced, just so we just do return ABC from string 1. Nice. Okay, good, I seem to understand it. We're gonna take a look at this problem again tomorrow. Hopefully I remember. I think we will, but yeah, in the morning when we come back to it, we're gonna do this problem again and kind of re-solidify it in our head, kind of how it works, just to get that intuition up a little bit. But yeah, I appreciate you guys watching. It's been a good day, so hopefully I'll see you guys again tomorrow. Thank you guys. See you later.